Hi, welcome to this webinar. In this session, we'll be discussing advanced simulation training for radiological identification devices. My name is Craig Duff. I'm the Director for the Products and Programs for the Radiological Nuclear Products within Kromek, and I'm delighted to be joined here with Argon Electronics.
Thank you, Craig, for the introduction. I'm pleased to be here with you both today. And I'm Felipe. I'm Director of Business Development in Argon. We specialize in training simulation, and you're going to hear a lot about us today.
Hi everyone, I'm R. Jackson. I'm ex-British Army. Been in CBRN for a while, and I am now a training consultant.
The CBRN landscape has become increasingly defined with state conflict and an increase in terrorist activity. Since the early 1990s, the IAEA reported over 4,000 incidents of illegal or unauthorized movement of radioactive materials. So training of security and military personnel has become essential to combat that threat.
So I think CBRN training has increased in pace, and it has taken center stage in the last 5 to 10 years. But of course, safety is non-negotiable in training. So live agent training is very much limited by the availability of radioactive material and the safety experts on site. So the students have a very limited time to actually conduct the training itself. So the training burden is increasing because of the threat picture, but the training cost hasn't changed, so the cost is still high. So I think that's where the simulators come in. So because they reduce the cost hugely, they eliminate the need for live radioactive sources and the safety factor that goes with that.
Yeah, it makes sense. The ownership cost at the end of the day becomes much better when you use simulators, because at the end of the day, you're not dealing with real sources. It's supposed to be a risk-free, depending on which simulation devices are you using. In the case of what we're showing today, it's a risk-free simulator, right? So also in terms of the limitation, there are so many things that you can do with simulators that you might not be able to do with live sources. It's typically, the live sources are typically low activity level, which becomes a burden. If you're actually training for an emergency, you need something that replicates or simulates the actual emergency, and that typically is not only low activity level sources, right? So we've come up with this technology that we're going to talk about, where you can actually simulate high activity level. You can control it. It's absolutely flexible, but especially today we're going to talk about RIID. And this was a partnership that we did with Kromek, and we're very proud of it.
And at Kromek, we do a lot of user training. So when customers purchase our instrument, we'll go to site, and then it's a common problem as to do they have radiation sources to do that training with. So the ability to do simulated training makes it a lot easier to do that. Another addition is it's very difficult if the nuclear material is special nuclear material. There's only a few licensed sites where that would be accessible in order to be able to create that simulator with that material with this device. Makes what just traditionally would be impossible to do in practice.
I guess that from your training perspective, using real sources will limit the ability for some specific scenarios, right? Like if there's a lost source, as what Craig was saying initially.
Yeah, the
right.
bonus of this equipment, the training value is you can conduct training in any location, any scenario. You can conduct training on border crossing, for example, without closing that border crossing itself, and you can have teams running through a high radiation scenario without risking members of the public, of course. So it's extremely useful in that sense. Yeah. some of the biggest mistakes organizations make when they organize training. They rely heavily on theoretical and classroom training without getting people outside into the real world, into real scenarios. And you can read a book about training as much as you like, but without actually the pressure of the teams going out into the real world and conducting the training with PPE and detectors, the realistic to the ones that they're going to be using on the real mission. That is where effort should be maximized, instead of stepping out of the classroom as soon as you can, not spending too much time in the classroom going through PowerPoints and things. So you need to get the students out on the ground using the actual detectors.
It makes sense. You just get what you get from theory, right? Like, I can think about scenarios where you want to train for time and distance, right? And time and distance, yes, you can have the theory on the exposure, on the time that you can be exposed, on the threshold, right? But it's something different to know how much, and it's something different to be actually exposed to it and know what to do when the time comes, right? So I fully agree with what you're saying. I've seen trainings where the instructor just provide a reading if they don't have live agent sources or simulators, and what we typically call it is more like a rehearsal, or it becomes in fact an artificial training, because yes, you might have something that can trigger your devices, but in fact you're not training for the thing that you look in the theory, right? So yeah, it makes a lot of sense. So on top of the challenge that we have spoken about, there's an urgency for the training to be realistic when it comes to military and non-military and how they communicate within each other. Because when you're facing a real threat, a critical part of it is how do you communicate, right? And you can rehearse it, right? But it's completely different if you're training on communication when you're having an alarm, when you're having a real threat in your hand, that you're saying, okay, there's something we need to do, right? So communication becomes a key part, and between both type of agency, let's say military and non-military, it needs to be clear. So one, you need the scenario to be as realistic as possible. Without that, you cannot simulate that pressure. Two, you need a real data so that you can act accordingly. And what we're going to discuss today is part of that data is knowing what is there. It's not only about knowing what's the exposure, what is the threat, you actually need to identify it, and there's value in it, and that's what we're going to talk about today.
So further to the training and the communication of training using radioactive sources, if you're using live radiation sources, it doesn't give you much room for error, and definitely doesn't give you much room to practice when things go wrong and learn from your mistakes, because everything is safety driven. So having a simulator, you can have errors during the training, and you can take the students back through that training and step by step where the errors were created, what effect they would have had in real life, without putting operators at risk. So I think it's quite a beneficial side to using a simulator rather than a live source.
So today we have the D5 radiation identification instrument. This is a class-leading identifier used by government and security personnel around the world, produced by Kromek. Very successful device. This gives a medium resolution, gives a very accurate adjudication spectrum to be able to send back for reach back, and a very sensitive detector on it. The benefit of the system we're talking about today is we're taking an already established instrument, and then there's no changes to the device, there's no changes to the user interface. It's just an add-on via the USB port that the simulator receiver plugs into that USB port, and then this puts in accurate spectra into this device. So it will take the spectra which has been set up from the simulator device, incorporate that spectrum into this, create the real alarm. It will adjust your dose rate accordingly for how close you are to the simulator. It'll accurately identify it. It'll give you your spectra, and then you'll be able to send that back for detailed reach back as if it was a real environment.
On top of that, it's the first handheld spectrometer that we have created when it comes to the simulator, which is it becomes very interesting because this is literally not only the D5 launch, but it's also the capability launch. Like this is unique in the world, which is fantastic. Craig, you were saying about you were talking about the source, right? The simulator source. So I'm gonna just give a brief introduction about it. This is the gamma radiation source. The gamma radiation source is absolutely risk-free. There's no real radioactive sources in it. It's just our technology or IP. Basically, it gives you all the flexibility that you want to have in a training environment, right? So you can increase or decrease the activity level as per your needs. You can choose among different radionuclides, which, as you mentioned, it will give you the possibility to simulate multiple spectra. And that has a value on the training, which we'll cover later on. But it's to the point that it's so realistic that it can simulate not only the spectra, but also the inverse square law and shielding effect, which is basically the most important principle that you want to simulate when it comes to training. If you want to find a source that is hidden, you want to identify it, you use devices to that, and the most important thing is to know what is there, right? And basically that has some sort of challenges that the user needs to overcome, and that's depending on how the radioactive source behaves. This will give you that.
And customers can configure and incorporate their own radionuclides, their own shielding environments into the system.
So it comes with an app that gives you that flexibility. It's pretty easy to use. The source comes with 9 different levels. Each level will mean a different activity level, a different distance, right? But using that app, you can also configure the different radionuclides, and there's a wide variety. It's so yes, you can in fact do it. And I guess that this spectrometer will give you that ID, right?
So then you get the accurate identification on here, you get that spectra stored, and that's ready for reach back. And as we touched on earlier, when you're doing cross-agency training, how you then get the spectra off the device, as you would with any D5, the many ways you can do it via different networks. And that data then goes back to reach back, and then to make an adjudication decision. And that ability, as we touched on, to be able to do that with a simulator long in advance of this happening in reality, lets you refine that whole process.
So on the training side of life, this is very useful because if there is a threat picture or intelligence comes in for a border crossing, for example, in Europe, and you know a certain radioactive material might be crossing a national border, you can put that into the device and you can simulate that training, and the operators know what it looks like, how the device would behave in real life if that was the material crossing the border itself. And you can simulate the training specifically for the threat that you're facing, rather than generic training.
There's a history behind this technology creation, right? So Argonne partnered with laboratory, the Lawrence Livermore National Laboratory. This is a laboratory that is part of the BOE in the United States and the Department of Energy. And basically we partnered with them to commercialize the technology that they have created. So these development started many years ago, and basically the inventors of the technology found us because we were trying to achieve this technology by our own means, and they were working on this in parallel. They were highly advanced on the result that they wanted to achieve, and when they found us, they basically when they were looking for a partner, they chose us as their exclusive commercial partner.
So they're using detailed simulation tools to be able to produce that spectra.
Yes, and those details are embedded within our current technology. So this technology, we had it for gamma training simulation, but now it has an additional add-on, let's say, based upon the technology that they developed. Now, what is interesting about that approach is that one, the accuracy, the fidelity is pretty high, but on top of that, that partnerships allow us to refine it and improve that accuracy by getting support from the inventors, from the scientists, which are the ones that are in the forefront of the technology.
I think the partnership between Kromek and Argon has been a successful one due to we're both UK-based companies, which has made the collaboration very easy in terms of the development side of things. Kromek's well established within the customer base, and Argon is also established within that same customer base who do the training and simulation tools for that. So it became a logical fit for the two companies to come together to develop this technology to ease the strain on our customers for what we've been talking about today.
Yeah, I guess Kromek approach is quite similar to Argon approach in many regards. Innovation, like Kromek typically releases new product and you're at the forefront of that innovation, similar to Argon. And it made all sense because we've been working on training simulation for many years, and we were just looking for a way in how to keep on improving that capability, and Kromek was the ideal partner because your position, your brand reputation around the world is quite premium. People recognize Kromek as one of the leading companies when it comes to spectrometer identification.
And likewise with Argon, with simulation tools and products, that it was a logical fit. So training on the D5 detector, just touching on that, becomes very important rather than using a substitute. It makes it identical, so the screens are exactly what the users will see. There's no changes to the button presses, the combinations of presses, so everything's identical. When it comes to reach back, how you get the information off the device, there's so many different ways of doing that using the D5. So the spectra will be stored in a file which is ready for reach back. That can be taken off the device via USB or Bluetooth or Wi-Fi. It can be used via QR codes, which we've talked about in other webinars. It can also be compatible with different networks, so that data can go back to different networks via reach back. So a combination of everything from the user seeing everything which will be identical to what they are going to use in the field with that same device for both search, localization, confirmation, and exactly what they'll need to do to be able to identify what the threat is and be able to put in place procedures to handle that situation.
Yeah, we recognize that users prefer and they need and they want to train with their actual operational devices, right? And that's what we've done over the last almost 40 years. If you look at our history, the simulator that we have created throughout our entire trajectory are the identical replica to the detectors. What makes the D5 special is that the device that you use is your actual detector, right? You've covered this in the past questions. You just connect the module, but on top of that, what you're gonna find is that there are many agencies and organizations in the world that are already using the train simulation system that we provide. What we have created is an ecosystem, and this ecosystem, what allows different agencies around the world is if they already got your detector and they already got our simulation systems, it's just a matter of getting that module connected via USB-C, as you have just explained, and it becomes a training device. So it's a magical formula because at the end of the day, you have your operational detectors, your kit, the one that you want to work with, but you're simulating what the real emergency is, and you're not just using the live agent source that we were talking about earlier.
Yeah, and from the training perspective, I think it's critical in military or emergency services situations that you, as we say in the British Army, you train as you fight. So you have the same equipment and the same conditions, as close as you can get to them in training as there would be on a real operation. And that means getting muscle memory for all your equipment. You have the same in the military, you'd have the same weapons. In the emergency services, you'd have the vehicles that you would have with you and all your medical equipment and stuff like that. So it makes complete sense to have the detector that you're going to be using on an actual mission or an incident that you have in training. And because it's such a high pressure environment with the room for error so small, that training with the equipment that you have just reduces that possibility of things going wrong on the actual day.
With the ongoing conflicts in Eastern Europe and in Middle East, accessibility to nuclear materials to bad actors has become a lot more easier to come by. What will be the knock-on effect within the UK we see with that, which will lead to the training?
Once control of material is lost through conflicts or for other reasons, it can find its way to bad actors quite easily and be smuggled across borders and find its way in the UK or with our allies and used for nefarious reasons, like, for example, a dirty bomb or some other device. So the more instability there is in the world, the more risk there is of this happening. So if you take, for example, the Martin's Law, which is the Protection of Premises from Terrorism Act, which will require large venues of 800 or more visitors to have a counter-terrorism risk assessment, basically. And part of that risk assessment will be training for the staff, for the venue staff, which could potentially see radiation training introduced into that as well. So to prepare for any eventuality of a terrorism attack and the actions to be carried out.
Now that you mentioned that, there is another challenge, and it is that governments are increasing the regulations to train and to use radioactive materials. We're saying this in Germany, where in the past few years, getting access to those low activity live agent radioactive sources, it is becoming increasingly difficult. So, but at the same time, you have these emergency response teams that need to increase and enhance their preparedness for these possibilities. It's not only the army who must be prepared, it's also the local and in-country agencies, right? So you have the two sides of the coin, right? So one is the bad actors have more accessibility to resources, but because of the situation that you both have explained, but simultaneously it's harder to train with real sources. So going back to the training simulators, it makes all sense. So going back to the question where CBRN, where we're looking in 5-10 years, it's a combination between people need to know how to prepare themselves better, because it is becoming increasingly risky, the situation worldwide. So on top of the gamma radiation simulator tools that we've spoken about, the D5 is also compatible with a simulation system that we can provide, which is called Bloom-SIM. And this system gives the ability to simulate larger scale area scenarios. So you can simulate, let's say, a radiological plume post-event or a radiological hotspot, and you can simulate different environmental settings that enhances that realism. Yeah, you can choose different radionuclides, so the D5 will give you different ID, different spectrums. But the idea is that this software gives the ability for the command control station to make the right decisions when the time comes, because these large scale area trainings allows multiple agencies to be immersed in that same training scenario and enhance that communication procedures. So yes, it does it. And on top of that, you can review what just happened in the training scenario. So there's an active action review mode, which gives you not only what happened with the thread, but also the player movements, the readings, the exposures that they've got. So yes, it's a very interesting capability that clearly you cannot do with live agent sources, because at the end of the day you would have a real disaster.
During training serials, it's really difficult to make training feel realistic. And having done a lot of live agent stuff in the past, live agent training, you normally know where the hazard is because there's a safety person there, a scientist or a safety manager, and you know the source is going to be nearby because they're managing the scene. So if you have a simulator that doesn't need a radioactive source, of course the training is much more realistic. And especially saying about the plume sim, you can simulate you can train in an environment which would otherwise be impossible to achieve, because there's no organization in this world which would let you disperse even a low radioactivity source in a wide area. And you can also pick any location to train in. You can train on the London Underground, for example, which would be otherwise impossible.
So that comes to the close of this webinar. So thanks to the audience for watching this. Hopefully it give a good description of this exciting development between the Kromek and Argon, which is now available. So any additional questions, please feel to get in contact with us.